Okay, and so here's that invoice doc that John from accounting sent over to us. And now we're here to perform our initial triage of this piece of malware. And so what we'll simply do is just drag and drop this potential malicious code into my favorite tool for static analysis, PE Studio. Simple as drag and drop. We'll let that populate again. It's taking a minute, it's analyzing. Looks like it is complete. Yeah. So as we were saying, we want to go back and think about some of the pertinent information that we can pull from the PE header. And this is the structure of what a Windows executable will look like, to where it's showing our strings. And strings are just ASCII characters that are found throughout the binary. We have our exports, our imports, that we should really be focusing in on. These are going to be the bulk of our analysis from this static phase. And here we are given the MD5, SHA-1, SHA-256. Just think of hashing as sort of a fingerprinting methodology, and it gives that hash, well, it gives that file its individual fingerprint. However, like I was alluding to, I take the hashes with a grain of salt, only because malware authors can make slight changes to the actual malware without actually changing the actual functionalities of it. And so that slight change inside of the malware without changing the actual functionality can give us a totally different hash value. Okay. All right, and so let's analyze, and we can see that this is not a .doc file, okay? And the way we can figure that out, and this is important if you guys are jotting down notes, if we look at our first bytes in hex, 4D and 5A, and that converted into text is MZ. That 4D and 5A, MZ, is always going to be an indicator that it's not a PDF, it's not a .doc file, this is an exe file, this is an executable. So those are always indicators that you want to look for when performing your initial triage of a suspicious file. And what malware authors can do whenever they, say they're doing a phishing campaign or anything of that nature, they will change the extension of the file, and it will, thwart, our analysis efforts, because we're thinking that this is a doc file. How can this be malicious? However, it's an exe, and I'll show you. We can actually go back and change that extension to .exe, and it will revert back into to your traditional executable file. Okay. Other information that we want to pull from this, we have an imp hash. We also have an entry point. But I want to get down here to where it says file type. And PE Studio does a great job at just displaying this in such a beautiful manner. And it's showing us here that, hey, this is an executable. This is not a PDF. This is not a doc. It's not an Excel file. This is an executable. So, and here, it's giving us CPU, which is this is a 32-bit subsystems. Subsystems can either be one or two things. It could be the GUI, just a graphical user interface, or it could be the command line. So it'll either be one of those two. And next, I mentioned that we can determine if this file can timestamp. We see here that this piece of code was compiled Thursday, March 14th of 2013 at approximately 7:58 UTC time. That'll be something that we want to jot down within our documentation. Like I said, if we take it as a grain of salt, but it's good to document. So a lot of important information that we can get from here. This is just kind of the basic overview of what this file actually is. And so now if we want to dig deeper into its actual functionalities, we'll go and look at our strings, okay? And strings, again, are just ASCII texts that are found throughout throughout the file. And so what we'll do is we'll just literally go and just find anything that could be possibly interesting. So here we have b.cfg. We have a logs123.txt. So maybe this piece of malware is logging somewhere on our local machine. I see a persistence mechanism. And so what persistence means is the malware authors try different methods to, for one, conceal the malware on our local machine, or to make it run within the background of all of our other processes. And a key registry value that aids in persistence is the software Microsoft Windows current version and run. So this means that every time our machine boots up, this malware will run. So this is going to be an indicator of compromise. So we should probably go and investigate this registry key, see what's written there. Okay, see explore.exe, we see sdropper32.exe. That's pretty interesting, pretty evident. And we have another log123.txt. So maybe we should be looking for this within our file system. Well, I'll show you some of the tools and the dynamic aspects of our analysis that can show changes to the registry, the file system, or any type of processes that have been altered. And as we just scrolling through, we see some Windows functions or Windows APIs, which we'll get into once we go over into the import section of our table here. And just these are all the different functionalities, which we'll see in the imports again. And we're scrolling down, and it looks like we see some maybe commands going on here. Also, we see a possible C2 server. Whenever you guys see an HTTP or a URL within the strings of the malware, then that could be, we could hypothesize that maybe that this is the C2 server, or the command and control server that this piece of malware is trying to reach out, whether that be for data exfiltration or just to receive any type of commands from the back end on the hacker side. So that's just a wealth of knowledge within the strings. And again, strings are just ASCII characters that are embedded within the malware that we can look at and try to deduce some type of functionalities from, okay? A lot of pertinent stuff that we should be writing down in our analysis. Next, we'll move on to our imports. And imports are just, they're functions that are used by the malware. Windows has a wealth of functions that the malware can interact with in order for it to carry out its overall goal. And you don't have to know all of these functions. Microsoft, does a great job at documenting each of these and giving a very, very descriptive, gives them a very in-depth description of what each of these functions are capable of. And if you guys, you come across, let's just say, for instance, create mutex. You want to know what create mutex is, okay? You can go to the Microsoft MSDN documentations or just Google create mutex. I think one of the panelists earlier said that Google is our best friend in Google University. So yeah, you can Google what create mutex is, and it will give you a list or a description of what this function or API can do. I don't personally know all of the functions. I can tell you some of the key ones that we should probably look out for. For example, we see some changes to the registry. If you guys are familiar with the registry is just an overall configuration of our operating system. So a lot of changes that can happen in the registry can affect our host machine. And so here we can see that this malware is using the registry create key to probably create a new key. It's setting a new value within the key, which is probably used for persistence mechanism. It's opening the key, and we also see some internet activity to where it's actually trying to connect to the internet. You see it's trying to send requests out. So we can probably deduce that this piece of malware is trying to reach out over the internet to that command and control server that we found in our strings. So we'll make note of all of that stuff. It's opening the internet, just more internet activity. And again, you don't have to know what the actual individual functions do. If you can Google it, understand its functionality, then we can get a pretty good idea of what this malware is trying to do. And here, we're seeing it's opening and creating different files. We saw that file, the logs123.txt. It's writing to different files. So, and these are all the stuff, we'll dig deeper into what is actually going on behind these functions. But for now, this is just giving us a general idea as to what is going on.